Okay, so a quick recap of the important stuff for parabolas and possibly a little bit of ellipses as well. A parabola with vertex at 0, 0 and the x-axis is the line of symmetry is of the form y squared equals kx, where k is a constant. Looks like that. If you've got a stretch of scale factor c in the x direction and a stretch of scale factor d in the y direction, then you replace x with x over c, y with y over d in the original equation, and a similar thing applies if you've got an ellipse. So a centre 0, 0, radius 1 has the equation x squared plus y squared equals 1, so it's a circle. To stretch its scale factor a in the x direction and b in the y direction, you make it x squared over a squared and y squared over b squared. So it's almost the same except you've got the squared to worry about. It cuts the x-axis at plus or minus a and the y-axis at plus or minus b. The hyperbola stuff, I would probably watch the hyperbola video because I think I explain it clearly enough in that one, no point repeating it in here. So let's have a bit of a closer look at parabolas for today. Quick reminder as well, I suppose, equation of a new curve after a reflection in the line y equals x is obtained by swapping x for y and vice versa. Okay, and translations, if you're translating by that vector, then you replace x with x minus c and y with y minus d. We might need a little bit of that when we look at our question. So the question we're going to have a go at is this one. It's from June 2010, the AQA paper, the further pure one. A parabola P has equation y squared equals x minus 2. Sketch the parabola P. Now, obviously in your exam you're going to be using a ruler, however I can't find one right now. So I'm going to use this particularly handy pen. I have got some axes, don't need to be very exciting. X and Y. Now I know that if it was a standard equation, y squared equals kx, so in this case we're going to presume that the k is 1, then it would go through here, 0, 0, and up like that, symmetrical about the x-axis. But because I've actually replaced my x with x minus 2, that means there's been a translation. So if I replace my x with x minus 2, that means I've translated it by that. Okay, 2 across and 0 up. So if I'm going to draw this, instead of going through 0, 0, it's actually now going to go through 2, 0. Okay, it's about as close as I can manage, because as you may have noticed by now, my drawing not the best. So I've sketched my parabola, and then on the sketch I need to draw in the two tangents to P, which pass through the point minus 2, 0. So I might need to expand my thingy a little bit. Doesn't need to be accurate because we're going to do all the working out with algebra rather than with our drawing. The drawing just helps us to figure it out roughly. So if that's going to be my minus 2, 0 point, then I'm going to do a tangent, so it just needs to go through minus 2, 0 and touch the edge of my parabola, a bit like that. So they're my two tangents. So that's 4 marks already, and all I've done is draw a pretty picture. Well, fairly pretty. This is me we're talking about. So I've got my tangents drawn in. Show that if the line y equals m lots of x plus 2 intersects P, then the x-coordinates of the point of intersection must satisfy this equation. So we're going to have a little play around with some algebra and see how far we can get. Right, so if we've got, let's start with, we've got y equals m lots of x plus 2. Now our original equation is in the form y squared equals, so in order to make my life slightly less complicated, I'm going to square this. So if I square both sides, I'm going to square that part and that part, because I'd effectively be getting m times this bracket times m times this bracket, so I might as well just write it as m squared and then this bracket squared, like that. And that means I can then make it equal to my original equation, which was in the form y squared equals. So I've got now x minus 2 from my original equation is equal to m squared lots of x plus 2 squared. Okay, so we're now going to do a little bit of multiplying out and see what we get. X minus 2 is equal to, and then I'm just going to multiply out this bracket to start with. So that's going to give me x squared plus 4x plus 4. And then I'm going to move it along a little bit so I don't run out of room. I'm going to multiply this out, so I've got m squared x squared, and then I've got plus 4m squared x plus 4m squared. And then if I start putting those bits together, I'm going to bung them all over to this side, so I'll get 0 equals by the time I'm done, m squared x squared. And then putting together my x values, I've got 4m squared lots of x on this side already. And then I'm going to be taking away one lot of x from that side, so I'm going to have minus 1 there as well. So I'm just cheating and factorising straight away. You can do it the long way if you'd rather, entirely up to you. And then I've got plus 4m squared here, and then I'm going to be adding the 2 from that side over there. So that's what we were trying to get, m squared x squared plus 4m squared minus 1 lots of x, and 4m squared plus 2 equals 0. Okay, so we've got that part at the moment. And if the equation has real roots, then we need to show that. So the next thing that we're going to do is we're going to look at the discriminant, because if we're looking at roots, that generally means we want to be looking at the discriminant. So if it's got equal roots, then b squared minus 4ac, the discriminant, if it's equal roots, has to equal 0. But if it's less than 0, there are no real roots. If it's greater than 0, there are 2 roots. If it's equal to 0, there is 1 repeated root, or 2 equal roots, you can also say. So we're going to take our a, b and c from over here. So for clarity, let's write it out. We've got a is m squared, because that's our coefficient of x squared there. B is this thing, 4m squared minus 1. And c is 4m squared plus 2. Like that. Okay, so we're going to put that into our determinant here and see what happens. So b squared is going to be 4m squared minus 1 all squared. Take away 4 lots of, let's do a times c, so we're going to have m squared times by 4m squared plus 2. And then we'll do some multiplying out and we'll see what we get. So here we're going to have 4m squared times 4m squared will give us 16m to the 4. Then we're going to be taking away 4m and another 4m squared, sorry, and another 4m squared, so we're going to be taking away 8m squared, and then we're going to be adding 1. And this part, let's leave it as a minus 4 and then sort out your brackets first. So we've got 4m to the 4 there, this one times this one, and then we've got plus 2m squared there. So we'll keep 16m to the 4 minus 8m squared plus 1. And then we've got minus 4 times 4, so minus 16m to the 4. And then that's going to be minus 8m squared. Okay, and we're still trying to equal 0. So 16m to the 4, take away 16m to the 4, they're going to cancel out. And we're just going to be left with minus 16m squared plus 1 equals 0, which we can rearrange to 16m squared equals 1, which is what we were aiming for. Okay, so we've shown that if there's equal roots, just by a bit of manipulating the algebra, we've got to the 16m squared equals 1 that we needed. So hence, find the coordinates of the points at which the tangents from the point minus 2, 0 touch the parabola P. So hence means we're going to need to use this result. So let's just go ahead and work out what m's going to be. Or in fact, let's just work out what m squared is going to be, because in terms of substituting stuff in, we're only actually going to need m squared. So let's just leave it as m squared. So 1/16. Okay. So what we're now going to do is go back to our equation, and we're going to replace our m squareds with 1/16. Okay. So we're going to go back to this equation here. So we had m squared x squared, so 1/16 x squared, plus 4 lots of this, so 4/16 or 1/4 minus 1. Okay, so 1/4 minus 1 is going to give us -3/4. So we'll get rid of that actually, -3/4 x, and then 4 lots of this, 1/16, it gives me 4/16, so that's 1/4 plus 2, which is 2 1/4. I'm going to write that as 9/4 equals 0. Not happy working with these ones because fractions in quadratics are never fun, so let's multiply through by 16 and get rid of that. So if we multiply that through by 16, we'll get x squared, and then we're multiplying this by 4 and then by another 4 to make the 16, so -12x, and then plus 36 equals 0. And factorising that, we're going to get x minus 6 is equal to 0. So we know that our x value is going to be equal to 6. Okay, and then we just need to work out our y value, because remember we're looking at the coordinate where the tangents from the point touch the parabola. So we're going to have one there and one there. So we're going to have the same x coordinate but plus and minus y coordinates. So let's just go all the way back to the beginning and we'll have a look at the equation of the parabola, which is y squared equals x minus 2. So let's go back down here and have a look at if y squared, running out of room, if y squared equals x minus 2, y squared equals 6 minus 2, which is 4, so y is plus or minus 2 for the last part. So there are sets of coordinates. We can have, and let's again, we'll write it out just to be extra clear, 6 and 2, and 6 minus 2. Okay, so there are coordinates of the points where it crosses. So the question may say it's about parabolas, but really you don't need to know a great deal about parabolas. It is mostly just about, you've got an equation, you've got another equation, you're looking at points of intersection, and you're looking at roots, and then you're substituting back into your equation to find your points. So don't let the parabola part put you off. They are not actually that bad. The thing to remember is this bit here where you've got, this is the standard form of a parabola if you've got y squared equals k of x. So bear in mind that anything that's gone from there, any variation, is usually to do with the transformation that the graph has undergone. So in our one it was y squared equals x minus 2, so it had moved across 2 places. So you can use that to sketch it and to help you out with that stuff. Okay, so parabolas, not so bad. Ellipses, also not so bad. If you want a bit more on ellipses, then have a look at the, I think it's the January 11 paper I went through, question 6 I think it was, that was an ellipse kind of a question, and it covered things like finding the tangent to an ellipse, which might be useful. There's also a video on hyperbolas, so use that if you need a little bit of extra help on those, but hopefully that covers the lot.